Uh, Good morning, everyone. It's a pleasure to be here. Marie-Soleil, thank you for organizing the panel and inviting me. My name is Jean-François Roux. I'm with EcoCounter. EcoCounter, we provide systems to count pedestrians and cyclists. And I'm not going to talk about the system so much today. I'll be more talking about the applications related to safety. But just before I get started, motorized traffic have decades of data collection. I was looking on the Ministry of Transportation website. If you look between Toronto and the Quebec border on Highway 401, there's over 100 locations where you can get the annual number of cars that are going at different crossings and things. So they have a really great history of being able to count the number of cars, but also the speed and so on. And when it comes to doing the analysis, it's very good. I'm sorry, how about for pedestrians? Well, the pedestrian data is a little bit more limited. When preparing for this presentation, I found this graph that is not super clear, but the one takeaway from it is it was done in 1961. So already then in Toronto, people were interested to know how many pedestrians were walking downtown. So the volumes of this data represents the volume between 12:30 and 1:30, and as you can see here, the thicker the line is, the busier it was. So already back then, they were trying to, find out how many pedestrians were using the sidewalks and the intersection. So it's been a subject of interest for a long time. How about today? In Toronto, if you go on the website and you look for pedestrian data, what you see is a bit more organized, but very similar in terms of what it is. You will find pedestrians and vehicle volumes at intersections, obviously a bit more locations, but mostly between 7:30 a.m. and 6 p.m. with breaks. So what they do is, they will either install a manual counter, a person that will count manually, or some semi-automatic video equipment that will either process 2 hours, 8 hours, or 12-hour counts at these intersections. This is really great data because you have a very wide coverage. You can do lots of sites, lots of things. But is this enough for what we need if we want to be able to measure the pedestrian exposure, which is basically how many pedestrians do we have across the city? So the answer is no, it's not enough. In order to do that, one approach has been to combine two types of counts. First, the short-term counts that can provide the spatial coverage. So as they were already doing in the 1960s, measuring at the number of locations. But in order to get something useful out of it, you need to have the long-term trends. So the permanent counters to be able to to extrapolate the short-term counts or to build factors. So this is the key in building some kind of a model to tell you how many pedestrians are using different parts of the city. How can this be done, permanent count? We're not going to put someone with a clipboard, for a year on the sidewalk. That'd be a little bit long. So we can use machines that are being installed. There are plenty of different types of machines that can be used. I'm going to give examples of two machines. So in this case, it's a box that is attached to a pole on an existing sidewalk. It will measure, it will use the difference in temperature when a person walks in front of the range, and it also record direction of travel. And what this equipment gives is some very interesting data. This is a week of data. It starts with the Monday, and we go all the way to the Sunday, and we have one data point per hour. And we can really, sense and we can really have accurate information on when the pedestrians are using the sidewalks, when what's the weight of a Monday versus the weight of a Saturday. And sometimes this graph does not show that, but sometimes we can find peaks of pedestrian travel after the typical, 7 a.m. to 8 p.m. where cities are usually monitoring information. For instance, in San Francisco, we had a case where they realized that their peak travel was between midnight and 1 a.m., which is everyone rushing back to the last train. So having equipment that monitor all the time will provide you much richer information. So this is a week, but if you want to have something a little bit more robust, you need to also have some permanent stations. And these stations, they can be video camera. This is a thermal video camera that is installed in this area. This is a street in Montreal where we have sensors on both sidewalks. And this data, we can see that on the east sidewalk, we have about, not quite double, but a little bit more traffic, and it's constant over time. This graph shows, this graph is per month, so it's between January 2017 until May. And I mean, what's interesting is that first you can see, well, there are more people walking in May than in January, but you can see there's a kind of ratio between the different sidewalks. And perhaps you're trying to getting to where I'm going, but what's interesting with this is to be able to see the trends and know when the people are coming. Another example, this is in Calgary. This is on Stephen Avenue. This is in an area that is shared between pedestrians, cyclists, and taxis and buses, I believe. So these sensors are installed, same type of sensors. And on this graph, I'm showing year 2015 and 2016. So you can see that the weight of the different months, there's some kind of consistency. And one thing to notice is the July data has over between 600,000 and 700,000 pedestrians per month. That is a lot of people. There are lots of people using this space, and it's important to be able to have this information. And also the fact that you've got twice the number of pedestrians in July than you have in January. So these permanent sensors are there to develop some expansion factors. This is the work that has been done in Montreal. So the first graph to the top. In red, you have the weekdays, and in green, you have the weekends. So if you have, a couple of hours of counts during the day, you can use these factors to convert a 2-hour count into a daily value. So that becomes very useful. Then once you have your daily value, you can turn this into your weekly value. And once you have your week or your month, you can turn this into a yearly value. Sorry. So we can see that by combining the short-term counts, whether they're done with a clipboard or with a machine, and long-term counts, we can get a pretty good understanding of how many people are walking in different areas. And how does this link to safety? You might ask yourself. So I'm going to talk about a little case study in San Francisco. Roger from the City of Toronto was showing a map that was very similar to this earlier today. So every point is collision or pedestrian-involved collision. And if you're familiar with San Francisco, you might see that around the downtown area, there's a little bit more of collisions. It's to be expected, but in the context of limited resources and lots of work to do, what do you do with this? How do you prioritize? Well, so we have the number of collisions, and then if we can find the number of exposure of number of pedestrians that have been crossing at the same time, then we can develop a collision rate, which is a risk indicator that it becomes very useful in prioritizing. So in order to do that, of course, they cannot put machines everywhere, so they combine a series of manual counts at intersections with some data that they got from the permanent counter, so they can build numbers that are represented the whole year. So once we look at this, if we combine the collisions and the volumes, we have a map of the risk. And you might have noticed that in the downtown area over here, the risk is smaller than in some other areas where you have fewer pedestrians, but maybe more collisions. And we talked about prioritizing and making actionable plans. So you can build maps like this, which is a top 20 of the intersections with the most risk, which for a city can become a very actionable plan. It's something that you can, it's something very achievable. If you just look at the map of all the collisions, then it's maybe overwhelming. Well, in this case, it's a little bit easier to do. So that's what I wanted to talk about today. I would like to thank Robert Schneider from University of Wisconsin-Milwaukee for providing some of the content for this, and also Luis Miranda Moreno from McGill University. Thank you.